Hi, in this video we are going to discuss pH and buffer solution. One drop of acid, one shift in pH. That tiny change can turn safe water into something harmful or make your blood unfit to support life. pH control more than you think. In this video you will finally understand what pH really means. pH is the potential of hydrogen. pH tells us about the number of hydrogen ion or hydroxyl ion indirectly in 1 liter of water. If 1 liter of water contains more hydrogen ion as compared to hydroxyl ions, then the pH will be lower and the medium will be acidic. While on the other hand, if 1 liter of water contains more hydroxyl ion as compared to hydrogen ions, in that case pH will be higher and medium will be basic. Actually, the pH is negative log of hydrogen ions concentration. This means that if there are more hydrogen ions, the pH will be lower. How we can say that the pH is lower or higher? We compare the pH with standard or reference point, which is pure water at 25 centigrade. 1 liter of water has pH 7, which is the reference point. Let us calculate the pH of 1 liter water. 1 liter of water is almost equal to 1000 grams. And 1 liter of water contains 55.5 moles of water, which we can find out by dividing grams to its molecular mass. Water is a weak electrolyte. Out of 55.5 moles of water, only 0.0000001 moles of water dissociate into their ions, which is 10 power minus 7. Now, as we know the number of moles of hydrogen ion or the concentration of hydrogen ions, we can find out the pH of 1 liter pure water at 25 centigrade by using formula which comes 7. Now this 7 is the neutral point or reference point. Those substances which have pH from 0 to 7 are being considered as acidic, and those substances which have pH from 7 to 14 are being considered as basic, and those which have 7 are neutral. 1 mole of water also have pH 7 as 55.5 moles of water. This is because 1 mole of water have smaller volume, which is 18 milliliter, and have same ratio or same concentration of hydrogen ions as 55.5 moles of water have. And when we discuss strong acid, they completely ionize in water. For example, when we dissolve 0.0001 mole of nitric acid in 1 liter of water, this dissociates completely. This is because nitric acid is stronger acid and water is a very good base. So 0.0001 mole of nitric acid gives same amount of hydrogen ions. We can also find out the number of hydrogen ions, which are trillions. Now, as we know the number of moles of hydrogen ion or concentration of hydrogen ions, we can calculate the pH of that aqueous solution. What power I should rise to 10 to get 0.0001? This is 10 power minus 4. Now, by solving log, we can find out the pH of 0.0001 mole of aqueous solution of nitric acid, which comes out 4. So this is acidic. As the number of moles increase, the pH decreases. For example, 1 mole of nitric acid in 1 liter water have pH 0, 0.1 mole of nitric acid have pH 1, and 0.01 mole of nitric acid have pH 2. This is because we take the negative log of number of moles or concentration of hydrogen ions. Now the question is this: why we take negative log of hydrogen ions? This is because number of moles are very small and number of particles are very large. We just simplify numbers by taking negative log. When we discuss strong bases, they also completely ionize in water. For example, 0.01 mole of sodium hydroxide, which is strong base, completely ionize and gives 0.01 mole of hydroxyl ions. We can also find out the number of hydroxyl ions, which are trillions. Now, by using same formula, we can find out pOH by taking negative log of hydroxyl ion concentration. We can convert 0.01 to 10 power minus 2. Now we can find out pOH, which comes out plus 2. This is a rule that sum of pH and pOH is always equal to 14. Now by putting the value of pOH, we can find out pH, which is 12. This number indicates that sodium hydroxide is very basic. Weak acid do not completely ionize, and we cannot find out their pH by direct using formula. For example, we have 0.1 mole of acetic acid. At initial time, there is only 0.1 mole of acetic acid. And at the time of equilibrium, X mole of acetic acid dissociate and form X mole of acetate and X mole of hydrogen ions. Now we have to find out the value of X mole of hydrogen ions by using ionization constant of acid to find out the pH value. Ionization constant of acid is the ratio of concentration of product and concentration of reactant at the time of equilibrium. Here the value of X is very small because very small amount of acetic acid dissociate. Now by putting the value of acetic constant, we can find out the value of X, which is the number of moles of hydrogen ions. By simply solving, we can find out the value of X, which comes out 1.3 cross 10 power minus 3. Now, as we know the number of moles of hydrogen ions or concentration of hydrogen ions, we can find the value of pH of 0.1 mole of acetic acid by using formula, which is 2.87. So, for weak acid, we cannot measure the value of pH directly by using formula because they do not ionize completely. And when we mix acid and base, then also we can find out the value of pH. For example, we mix 0.15 mole of hydrochloric acid and 0.1 mole of sodium hydroxide. 0.15 mole of hydrochloric acid dissociate and form 0.15 mole of hydrogen ions. And 0.1 mole of sodium hydroxide dissociate and form 0.1 mole of hydroxyl ion. Both completely ionize because they are strong acid and base. This aqueous solution contains 0.05 mole of hydrogen ions more as compared to hydroxyl ion. So 0.1 mole of hydrogen ion and 0.1 mole of hydroxyl ion combine together and form water. And 0.05 mole of hydrogen ion remain in aqueous solution and make it acidic. The medium is acidic, but still we can find out the value of pH by using formula. Here we can convert 0.05 to 5 cross 10 power minus 2. Now by simply solving the negative log, we can find out the value of pH. Aqueous mixture containing 0.15 mole of hydrochloric acid and 0.1 mole of sodium hydroxide. Which comes out 1.30. This indicates that the mixture is acidic. Let us now we discuss buffer solution. Buffer solution resists to changing pH. Just like sponge which absorb excess water and keep clean, buffer solution absorb excess hydrogen or hydroxyl ion and keep the pH stable, even when we add hydrogen or hydroxyl ion in the solution. When we see the chemical composition of buffer solution, we see that it consists of weak acids such as acetic acid and the salt of that weak acid, which is sodium acetate. Sodium acetate completely ionize in water and form acetate ion and sodium ion. We can also form buffer solution by using weak base such as ammonia and by using salt of this weak base, which is ammonium chloride. In aqueous solution, ammonium chloride dissociates completely and form ammonium ion and chloride ion. How different buffer solution work? When we add acid in buffer solution, acid gives proton. Salt of weak acid such as acetate ion combine with that proton and form weak acid, which is acetic acid. This is a weak acid, not dissociate completely or dissociate in very small amount, so do not disturb pH. So we can say that when we add acid, it is the proton of that acid which can disturb pH. But the buffer solution contains salt which absorb that proton and so pH almost remains same. And when we add base in buffer solution, base gives hydroxyl ion which can disturb pH. But buffer solution contain weak acid. Hydroxyl ion extract proton from weak acid and form water and acetate ion. So we can say that the weak acid of the buffer solution neutralize the effect of the hydroxyl ion and keep the pH almost same. Buffer solution use common ion effect. In the above discussion example, acetate ion is the common ion. This ion acetate come from weak acid acetic acid and as well as from the salt of weak acid sodium acetate. So according to Chatelier principle, common ions suppress the ionization of weak electrolyte or weak acid, which is here is the acetic acid. So this common ion or acetate ion suppress the ionization of acetic acid and do not allow it to produce more hydrogen ions. So in this way buffer solutions keep their pH stable. Let us now we discuss buffer capacity and pH of buffer. Buffer capacity is the capability of buffer to resist the change of pH when acid and base are added. Buffer capacity depends on the concentration of weak acid and the salt of that weak acid. For example, when we make buffer solution by mixing 0.1 mole of acetic acid and 0.1 mole of sodium acetate, and make another buffer solution by mixing 1 mole of acetic acid and 1 mole of sodium acetate. The second buffer solution have the higher capacity. This buffer solution have the higher capability to resist the change of pH. Buffer solution have specific pH, which we can calculate by using Henderson equation. Through this equation, we can find out the pH of buffer solution before and after adding acid and base in the buffer. This determines buffer capacity. For example, we make a buffer solution by mixing 0.1 mole of acetic acid and 0.1 mole of sodium acetate. Here the concentration of weak acid and its salt is same. Now by using Henderson equation we can calculate the pH of this buffer solution. As the concentration of acid and salt are same, pH value depends only on pKa value. pKa value of the acetic acid is 4.76. So this buffer solution has pH 4.76. Now we add 0.01 mole of hydrochloric acid in the above 1 liter buffer solution to check buffer capacity. As we add strong acid 0.01 mole of hydrochloric acid, it dissociates completely and the number of the hydrogen ion increase. And we can also say that the concentration of the acetic acid changed from 0.10 mole to 0.11 mole. And the concentration of the salt changed from 0.1 mole to 0.09 mole. So we say that 0.01 mole of hydrogen ion from hydrochloric acid react with acetate ion or salt and form acetic acid. So the concentration of acetic acid increase and the concentration of acetate ion or salt decrease. Now the concentration of acid and salt are different. Now we put this value in the Henderson equation to find out the pH value. We put the concentration of the salt, which is 0.09, and the concentration of the acid, which is 0.11. And we simply solve this equation by adding pK value to find pH, which comes 4.67. The pH of buffer solution was 4.76, and by adding hydrochloric acid, the pH changed from 4.76 to 4.67. This is a very little change as the hydrochloric acid is a very strong acid. This can bring a big change without buffer solution. Our body has specific pH. Digestive system, enzyme, and metabolism only work at that specific pH. In our body, carbon dioxide and water combine together and form carbonic acid. This carbonic acid and sodium bicarbonate in our body form buffer solution, which stabilize the pH of our body. When we eat acidic food or drink lemon water, these donate hydrogen ions, and hydrogen ion is just a bare proton which is very hungry and reactive and can destroy our body. But the buffer solution of our body contains sodium bicarbonate, which gives bicarbonate. And this bicarbonate absorbs that protons and form carbonic acid, which is very weak acid and do not disturb our pH. Carbonic acid is a weak acid, further it dissociates into carbon dioxide and water. And we exhale that carbon dioxide. pH of our body remains little bit basic from 7.35 to 7.45, and a minor change can cause death. So we should thanks to buffer which stabilize the pH of our body. Thanks for watching this video and please comment if you have any question.